All right, guys, we're going to look at the 2022 IEB paper question 4.2. Okay, so first of all, we're working with a probability density function. And remember, a probability density function is a continuous data as opposed to probability mass function, which is for discrete. Okay, the important thing to remember about probability density functions is that your probability, just like in a normal distribution table is probability density function. Okay, and like that, the probability is the area under your curve. So if you were looking for the probability that x lies between a and b, it would be the integral between a and b of the function with respect to x. So the first question, which was okay, pretty much Christmas, you've got f of x on this axis, and you've got battery life in tens of hours on that axis. Okay, and the probability of your battery lasting that long, in other words. So f of x is that function over here. So between 0 and 4, I've got to draw the straight line graph y is equal to x over 32. And all I simply do was when x is 0, y is 0. And when x is 4, I substitute it in, I get a probability of 1 over 8. So that's a 0.4, 1 over 8. It's a straight line, I join it up. That is the first part of the function between 0 and 4. The next part of the function is a horizontal line y is equal to 1 over 8, and that occurs between 4 and 10. Probability of battery is lasting longer than 10 times 10, 100 hours is 0, in other words. Okay, so the first question, so that's question A, that full marks Christmas time. Have your 4, 10, battery life, function value, that's not probability, that's your function value. Your probability is the area under the curve. So that's the end of question A. Question B said show that the probability x is greater than 3 is equal to 55 over 64. So I'm looking for this area under the curve between 3 and 10, which is made up of this area over here plus this area over here. Okay, so your probability that x is greater than 3 is equal to this area, which is the integral between 3 and 4 of x over 32 with respect to x, plus the area of this rectangle. So you could say the integral between 4 and 10 of 1 over 8 with respect to x will give you the same answer. Or you could just say the area of this rectangle, well, this distance here is 6, this distance here is 1 over 8, but as I say, you could have said the integral between 4 and 10 of the function is 1 over 8 with respect to x, and you get the same answer. So I use the rectangle, and I said, so this on your calculator gives you 7 over 64. Okay, this, okay, and then this area over here, okay, it's going to be area of a rectangle is length times breadth, so it's 1 over 8 times 6. Okay, and I end up with, as I hoped for, probability that x is greater than 3, it's 55 over 64. So this whole area over here, the area under that curve, is 55 over 64. Right. Question C, they say, 2 batteries are required for a torch to work. They both have to be working. The torch will only work if both batteries still have energy. Vince fits 2 new batteries into the torch. Okay. Determine the probability that the torch will stop working within the next 30 hours. Okay. So we know, so in the previous question, they said that the probability x is greater than 3, but they said show this. Now, when they do that, chances are we need that information for the next question. Otherwise, they'll just say work out the probability that x is bigger than 3. But they said show that, which means we probably need that answer. So they told us that the probability x is greater than 3 is 55 over 64. But x stands for tens of hours. So what we worked out is that the probability that a battery lasts longer than 30 hours is 50 over 64. Okay. Now you've got 2 batteries. Okay, you've got battery 1 and you've got battery 2. You can think of a tree diagram, you don't have to, you can just think about it. Okay. So the probability that battery 1 lasts longer than 30 hours is 55 over 64, and that doesn't is 9 over 64. Okay, the probability that battery 2 lasts, that independent events, battery 1 has got nothing to do with battery 2, that's why we represented with the tree diagram. Okay, that probability of battery 2 lasting longer than 30 hours is also 55 over 64. Okay, so in order for the torch to work, L1 stands for the last longer, L2 means battery 2 lasts longer. Okay, you work out the probability that battery 1 lasts longer than 30 hours and battery 2 lasts longer than 30 hours. And the way that will happen, for the probability that you follow in this part over here, so it'll be 55 over 64 times 55 over 64, which is 55 over 64 all squared. But we're not looking for the probability that they last longer than that. We want to know the probability that they last less than that. In other words, we want to know the probability that battery 1 and battery 2, there's a knot here, don't last longer, and that'll be equal to the negative space, the complementary space. So either they both last longer or they don't. Okay, so it'll be 1 minus that, which is 0.62615. The other way, so the probability, the question said that it lasts less than 30 hours, okay, well, in other words, it will stop working within the next 30 hours, is 0.2615. Both of them. You couldn't see it on here because it's working with 2 batteries. Okay. The other way we could have done this is we could have used this. We could have used the tree diagram directly, and we said, for the torch to stop working, 1 battery must. For the torch to stop working, 1 battery must not be working. So either you can have, I'm going to do it in yellow, this one lasts, the first battery lasts, but the second one doesn't. So that's going to be the route to that. This is a direct route instead of using the complementary space. So that's a way, one route for the torch not to work in under 30 hours. Okay, there's another route for the torch not to work, which is, well, the first one doesn't last, but the second one does last. That will also be 9 over 64 if I follow that route, times 55 over 64. And the third route would be this one in green here, where the first one dies and the second one dies, which is 9 over 64 times 9 over 64. And you work that out to get the same answer, 0.2615. So the trick was to remember, okay, once you work, look for those hits in the paper. If they tell you show something, chances are you need that information for the next question. Okay, in this case, because you're working with 2 batteries, the diagram didn't work. Right. Okay, guys, hope that helps.